Good evening everyone. My name is Kanishri K and today I'll be explaining the introduction, the need for MERN-Stack, the overall working process and the front-end part of our music player web application which we developed as part of our MERN-Stack internship project. This project is a full-stack web application which means it includes both front-end and back-end working together as a single system. In real-world applications, users never interact directly with the database or server. Instead, they interact only with the front-end interface and the front-end communicates with the back-end to process data and perform operation. This separation improves security, scalability, and user experience. We choose MERN-Stack for this project because it is one of the most popular and efficient stacks for modern web application. MERN stands for MongoDB, Express.js, React.js, and Node.js. One of the biggest advantages of MERN is that it uses JavaScript across the entire application from the front end to back end to database interactions. This makes development faster, easier to maintain, and reduces the learning curve. MERN is also highly scalable, performs well for real-time applications like music streaming, and supports JSON-based data flow, which is ideal for handling APIs and dynamic content. Additionally, MERN has a large community and strong ecosystem which helps in debugging, learning, and improving the application. Now coming to the working process of our application, the flow starts from the user interface. When a user performs an action like logging in, searching for a song, or playing music, or adding a song to the favorites, the request is first handled by the React frontend. The frontend sends the HTTP request to the backend using APIs. Backend, which is built using Node.js and Express.js, receives the request, verifies authentication if required, processes the business logic, and communicates with MongoDB to fetch or update data. Once the operation is completed, the backend sends the response back to the frontend and the frontend updates the UI instantly without reloading the page. The entire process happens smoothly in the background, giving user a fast and interactive experience. Now I will explain the front-end part of the project in detail. The front-end is responsible for everything the user sees and interacts with. Our main goal while designing the front-end was to create a clean, responsive, and user-friendly music player interface. We developed the front-end using the React.js, HTML, CSS, and JavaScript along with the additional libraries like Axios for API calls, React Router for the navigation, and Redux or Context API for the state management. The frontend is structured using reusable React components which makes the application modular and easy to maintain. At the top level, we have the root components that controls the overall layout and routing. We use React Router to navigate between different pages such as the home page, authentication page, and the profile page without reloading the browser. This gives the application a smooth single page experience. The navigation bar or the side menu allows user to easily move between sections like home, playlist, favorites, and profile. The main content area dynamically displays the song and playlist fetched from the backend. We use components such as song grid or song list to show songs detail including the title, artist, album, and the cover image. These components receive data from the state and render it dynamically on the screen. Song data is fetched from the backend using Axios GET-REQUEST. Once the data is received, it is stored either in component state or in the global state. This allows us to reuse the same data across multiple components without repeated API calls. Playlists are also managed efficiently. We limit the number of songs per playlist to improve performance and usability. One of the most important components in our frontend is the audio player. The audio player provides full control over music playback including play, pause, next, previous, shuffle, repeat, volume control, and sync functionality. It also displays the currently playing song details and the name, artist, and the album cover. The audio player stays synchronized with the playlist and the favorite, ensuring a seamless listening experience. We also implemented a search feature that works in a case-insensitive and real-time manner. As a user type, the front end filters and displays matching songs instantly, which improves usability and makes the navigation easier. Users can mark songs as favorites, and these changes are immediately reflected in both the front end and back end. Playlist management features allows user to add or remove songs easily. The profile section allows user to view and update personal details, change password and update image profiles. All these features are protected and accessible only to the authenticated users. Overall, the front end plays a crucial role in ensuring smooth interaction between the user and the system. It continuously communicates with the backend through secure APIs, updates the UI dynamically, and provides a fast, responsive, and engaging user experience. With this, I conclude the introduction and front-end explanation, and now my teammate will explain the backend implementation and conclusion.
Good evening all. I am K. Lakyapriya and I am here to explain the backend implementation of our music player web application. The backend is responsible for handling all server-side operations such as authentication, authorization, database management and business logic. We build the background using Node.js and Express.js and MongoDB is used as the database. The backend communicates with the frontend using HTTP request and response. In our application, we use common HTTP methods to perform the different operations. Get is used to fetch data. Post is used to send new data to the user. Put is used to update entire data where all fields must be resent. Patch is used to update only specific fields and delete is used to remove data. These methods help us to follow proper reset API standards. Whenever a user performs any action from the front end, such as sign up, login, or fetch songs, the front end sends an HTTP request to the backend. Based on the port number, the request reaches the backend server. And using routing, it is redirected to the correct API path. This request response cycle happens for every backend operation. Okay. Now I will explain the authentication flow using JWT tokens, which is one of the most important parts of our background. The steps followed in authentication are sign up, login, accessing protected routes, forget password, reset password, and profile editing. Starting with the sign up. When a user submits the sign up form, the backend first receives the request and destructures the data. It checks whether all required fields are entered or not and verifies if the email ID already exists in the database. If the email ID exists, an error response is sent. If not, the user avatar is uploaded to the cloud using ImageKit and the returned image URL is stored in the database. Before storing the data, it is converted into the correct format based on the schema defined in the user model. One important step here is password encryption. Before saving the password in MongoDB, it is encrypted using hashing. So no one can see the original password. After successful sign up, a JWT token is created which allows the user to be automatically logged in after registration. Second is the login process. When a user enters their email and password, the backend first checks whether the email exists in the database. Since the password are stored in hashed format, we cannot compare them directly. So we use a compare password method to match the entered password with the hashed password in the database. If either the email or password is incorrect, an error is written. If both are valid, a new JWT token is generated and sent to the front end. This token is important because it allows secure access to protected routes and is generated when the old token expires. Now coming to the protected paths. Some parts of the application should be accessed only by the authenticated users, such as profile editing, favorites, and playlist management. For this, we created protected routes. From the front end, the JWT token is sent in the authorization header along with the keyword bearer. The backend checks whether the token exists, extracts it and verifies it using the secret key and expire time. The token is valid, the user ID is extracted from it and the corresponding user data is fetched from the database and stored in a request.user. Then the request is allowed to proceed. If any steps fail, the user is marked as not authenticated. Next is the forget password feature. When a user clicks the forget password, they are asked to enter their email ID. The backend checks whether the email exists in the database. If it exists, a reset token is generated, hashed and stored in the database along with an expiry time. An email is then sent to the user containing a reset link with the token and attached to it. We use Mailtrap for sending this email. When the user clicks the link, they are redirected to the reset password page. In the reset password process, the token from the URL is extracted and hashed. The backend searches for a user who stores reset token, matches the hashed token and checks whether the token is still valid. If a match is found, the user is allowed to set a new password. The new password is again hashed and updated in the database. Next is edit profile, which is also a protected route. Only authenticated users can access it. The backend retrieves the user ID from the protected route middleware and updates the user details based on the new data received from the front. If the user wants to change the password, they must enter both the old and new password. The old password is verified first, and if the new password meets the minimum length requirement, it is encrypted and stored. If the avatar is updated, it is also uploaded to the cloud just like during the sign up. Now coming to the song related background functionality. To fetch songs, we use a get songs function where Axios is used on the front end to make an API request, and the backend returns all song details from the database. For playlists, we implemented a get playlist by tag feature. The tag is extracted either from the request parameter or request body, converted into a string, trimmed, and a default limit of 10 songs is applied if no limit is provided. The backend then fetches songs based on tag ID and format. Finally, we have the toggle favorite feature, which is also a protected route. The backend first checks for the authentication, then it checks whether the selected song ID already exists in the user favorite list. If it exists, the song is removed. If it is not, then the song is being added. The updated favorite list is then saved in the database and reflected immediately in the front end. Overall, the backend ensures a secure authentication, proper authorization, efficient data handling, and smooth communication with the front end, making the application reliable, scalable, and safe for real-world usage. Okay. Now I'm here to explain about the project which we built during this period of our internship. So this is how our homepage of our application music player app looks like, and here you like already I have signed in. I have already signed in, and now I have been logged into it. So only logout option is visible. But once when you are the new user to this app, you can see two options there: sign up and login. I will be showing all those things at the end of this video. And here are all the playlists which are available. You can choose any playlist which you want from this. Okay, now these are the songs which are available in our app. I will be showing a demo of playing one song. If you want to add this song into your favorite list, you can click here. Like this hearten button, it will be added into a favorite. To check out that, you can go to this favorite and you can see here. Once if you want to remove that favorite song, again you can go to the home page, tap again, like it is like a toggle option going on here, and these are the other options available where you can increase the sound, the speed at which the app like the song you want to run out. And here are the shuffle option, repeat option, all those are here. And in search, if you want, you can go and in this bar you can type whatever song do you want to search. See, I have searched overcome. Since you can see O is caps in it, as we have already told that it is a case insensitive, even if I type in small letter, it is working, and you can select from here and play the song. Okay, again we'll be going to our home page. Wait, I'll be showing how log out. Now it is, I have been logged out of this. You can see the sign up option here and the login option here. If you have already signed up, you can directly go to login and enter your email ID. You have to follow the placeholder values which are given here, like your name at then followed by email.com. Then next is our password. Minimum your password must contain up to 8 character. We have also included this eye icon so that the password which you enter will not be visible. Even though after login sometimes the user may forget their password, so they can use this option for doing forget password. If in case we do not have any account, if you are the new user to this app, you can go here and do for sign up. Okay, that's all. Thank you.